So Woolbeding, the Woolbeding Glasshouse, it's a building, kind of a relatively small building. It's 20 meters in diameter and it's 15 meters tall. It's diamond shaped. It's fully glazed. And the main characteristic that the building has is that it opens and closes. So it has a fixed base, which is 3 meters high. And then on top of it, there are 10, we call it sepals. So 10 triangles that open like a flower. So this is in a place in the English countryside where the client, which is a private individual that was sometime a gardener, and he wanted to have, so he had the possibility to build the glass house of his dreams, and this was a glass house that existed during winter but did not exist during summer. So it simply opens, and opening means that when you are inside, you have all the sensations of being outside, and the plants grow like they were outside during the summer, and then it closes during spring nights and also during all winter. So this was the main idea behind it, and also obviously the architect is Helric, which has a very distinct imagination, and he designed something that was beautiful in its own expression. Normally, when we have a building, we try to avoid movement as much as possible. Obviously, in every building there are parts that move. We are normally the doors and the windows. But on those parts, we try to do two things. The first thing is you try to avoid fatigue. So it moves in a way that the forces do not change a lot during the movement. And also you try to, since you need weather tight in most of the buildings, you try to make it close against something. And that something, normally it's fixed, or it could be, if you have a double window, another part of the window, so another moving element, but only one. In this case, we have 10 things that move, and that meet at a point, all of them. So each one, it's closing against another one that is also moving, and then they are not on the same plane. So this is quite a difficult thing in terms of weather tightness. And from the structural point of view, you have a lot of fatigue because you have a very big thing that opens and closes, and therefore in the way it opens, make that the forces that act on this element make a lot of fatigue to the thing moving, but also to the fixed space, because they are quite huge in comparison to the fixed space. The solution to this is simply to have an inflatable gasket. So this is a system that we had used in the past, but not to this extent. And it's a system which is more near to what it happens on a plane or into a railway, where you have a door that opens and needs to be weather tight, but the gaskets are inflatable, not as they normally are with the same shape all the time. This allows us to have this very thick joint and also to have tolerances, because it's not like a door where you can mount it to the frame, to assemble it to the frame and put everything together from your workshop to the site. No, you have to do this on site with a very big thing. So we had 15 millimeters of tolerance into the joint. And at the same time, it's so long that we have a deflection of about 5 mils. And this allows this 10 centimeters thick joint allows for a tolerance of, so allows for movement of 20 mils. If we start with the glasshouse closed, we have 10 cylinders with 10 hydraulic cylinders, which they have a force of about 1,000 kilonewtons. So they push the sepal to make it open from behind, from the bottom, so one part of the bottom, and then it moves, it rotates against an axis. yeah, this is how it opens and then closes in the other way. Once it's closed, then all the gaskets are actioned. It's quite simple. But what's not so simple is that if you have so there are 10 hydraulic cylinders, but if you go there, you will only see the cylinders. If you have an hydraulic system, you need a pump, you need a lot of things. They are hidden into an agricultural building nearby. So maybe that's something that you will not see if you do not understand how it works. The main thing that we learned is it's more of an attitude than of a concrete thing, because the things that we learned are very specific to the project. But the attitude is trying to understand. So if you want to design something out of the ordinary, you need to understand how the ordinary works, or at least if you want to, if you want to build it. So you can dream a lot, but if it comes to you, someone who has dreamed a lot, and okay, now I want this to be real, you have to ask yourself, why do we do doors in the way that we do them, and try to understand then how it will translate to make it totally different. So it's this attitude of trying to ask why we do the things like we do in normal practice that allows you to go beyond normal practice.